Hey, this is Matt from SpeedScale, and in this video, I'm going to show you how to increase the reliability of your AI coding assistant using Grafana's Pyroscope and SpeedScale's Proxymock. What we're going to do is reduce the cycle time for how long the AI has to think and let it test its hypotheses using the deep information you get from Pyroscope and then also the replay capability of SpeedScale. So if you're familiar with this problem, and if you've ever been an SRE or a sysadmin or a DevOps person, you're familiar with how you use an observability tool to track down problems. Generally what you do is there's an alert that fires, then you go and collect all the context information you can, metrics, logs, and traces. Then you go and you form a hypothesis, or your AI coding assistant forms a hypothesis. Usually it's a series of hypotheses, actually, more than one. Then you go and you try a fix. And if you're lucky, you have a testing environment, but it probably isn't the same as production. So you end up testing in production, and you're in this infinite loop here of token maxing, where the AI coding assistant can't figure out the problem necessarily because the cycle time's just too long, and your customers are experiencing problems as a result. Now, what I'm trying to do in this series of videos actually is reduce that cycle time. We're trying to get the AI coding assistant to get it right in the first try. So what that involves here is we're going to combine Pyroscope to get down to the line of code profiling information, and then we're going to test out all three hypotheses before we touch production. So it's just a much faster way of doing it. So without further ado, let me get into the exact demo and how this works. Okay, so first off, what is Pyroscope and what is Proxymock? So Pyroscope is a nifty utility offered open source by Grafana that actually uses a combination of techniques such as eBPF to essentially continuously profile running applications. So this is made possible by a new set of technologies, but this is a pretty good version of that. You can either upload it to up to a cloud bucket or take it to your local machine, whatever. In this example, I'm going to pull it down to my local machine. Now, Proxymock is a recording and replay system. So what it allows you to do is record a production system and then create a realistic production sandbox that looks just like the real thing. So that allows us to create these instant staging environments, so to speak. And they only look real enough for the tests that we're going to run. So recording is pretty straightforward. We put in here either through eBPF or through a proxy, we record. And then when we go and replay, we go and we send data to your app as if it's the real users, and we pretend to be the downstream dependencies. So that's how this is going to work. Let's get started. So I've already deployed a demo app that is stored in the SpeedScale demos repository. Now, there's a link in the description for a blog that will walk you through all these steps, and you can go get the link. So I'm not going to make the video longer showing you all the different pieces. But I've already downloaded the demo app using Get. Now, first thing I'm going to do is I'm going to run a demo app that communicates with an external service, just like a real application would. I'm going to use Proxymock to record the app running as it would be in the real world, and then I'm going to turn that into a set of regression and load test scripts that then the MCP or AI LLM can use to diagnose the problem. Our objective here is to use the Pyroscope data for deep dive information along with Proxymock to not only identify the problem, come up with a hypothesis, but also to test if our solutions work safely without actually breaking production. So without further ado, first thing I'm going to do is I'm going to start open three terminals because I'm going to have three different things going on at once. Your system will look very different in your CI pipeline, but this is just for our demo purposes. Now, the first thing I'm going to do is I'm going to run those backend services that my app relies on, and I'm going to do that using make catalog. Now, all this does is it runs a catalog with 15,000 records in it. The next thing I'm going to do is I'm going to start my recording. Now, I'm going to go ahead and set my recording directories. If you go look at the make file, you'll realize all these things are just wrappers around commands like Proxymock record, Proxymock mock, or starting up the Pyroscope. Actually, I forgot one step. First thing I need to do is turn on my Pyroscope instance. Now, I'm running everything locally. Again, you will have your own production instance of this, but in my local Docker desktop, I see here that Pyroscope has been started along with Alloy and the necessary bits. Okay, so next thing I'm going to do is I'm going to start that recording that I was talking about. Now what's going on here is Proxymock is starting your app, which is our demo app here. It's allowing it to connect with Catalog, but it's running in a little sandbox that allows us to capture all the traffic going in and out. This is only necessary because we don't have our eBPF collector deployed in production. Okay, next thing I'm going to do is I am going to run a curl command that will exercise the app. We're going to keep this simple. Okay. I run the app, I see that same number of records, it says some are valid, invalid, doesn't really matter. The demo app did some work, and it talked to that backend catalog service. Now, I've done my recording here, so I can stop my recording system. I don't need the catalog anymore because I don't need those back-end systems because from here on out, we're going to be running in an auto-generated sandbox that includes those downstream systems. Now, did it work? Did Proxymock actually record something there? Let's find out. If I run Proxymock Web, I'm presented with a Postman-like interface that shows me all the transactions going in and out of that container while we were recording. Now, you can see here that we have the inbound transaction. That matches our curl command. And again, just like a Postman UI, you see all the different requests and the header information, et cetera, et cetera, et cetera. But also, I see my downstream system, which is that catalog system. I see the request. I see a gigantic response full of text, which is all those different pieces that we need. And this is going to form a corpus for us to debug along with Pyroscope. Now, you can go learn more about that by watching our other videos. But in the meantime, let's keep moving. Okay, the next thing that we're going to do is we're going to establish correctness and performance baselines. Now, we only recorded one curl with one outbound connection, but that's actually enough using Proxymock to turn this into an actual load test. So the first thing I'm going to do is I've already stopped my catalog service. I've stopped the real backends, and I'm going to run everything from here on out into a custom sandbox that was automatically created by watching that traffic. So I didn't do any special work behind the scenes. All I did was run this command. So this wraps the Proxymock mock command, and we're pointing it at the same directory that we're recorded into, which has those RR pairs that I was showing before. Now, what that's going to do is we're going to simulate that backend catalog service so that we have repeatable results every time as if we had a real staging environment that's a 100% copy of production, at least on the application level. Okay, so it's all started up. We're good to go. Next thing we're going to do is we are going to establish functional and performance baselines. We're going to do that by just running a couple different configurations of Proxymock. Using that single curl now, it's going to scale it up to many, many V users and make it look like lots of traffic's going through. Now, of course, in this trivial example, it's going to be fairly straightforward because we just made one call. In a production system, this is going to be many, many sessions scaled way up. Okay. Now, while that's happening here, you can see that Proxymock is running through all kinds of tests, and it's scaling things up and doing a bunch of stuff at the back end. And the app is actually running in the Proxymock sandbox, talking to the back end mock server that is a direct replica of production. While we're doing that, it's probably helpful to mention that you're going to want to have 2 MCP servers started so that your AI has the best shot of doing a one-shot fix. Now, I'm showing Codex command lines here, but this exact same thing, just replace Codex with Claude. I'll actually use Claude for the next part of the demo, but you're going to add an MCP for Proxymock, which points at the local Proxymock instance that you installed in the getting started. And then we also have installed to the Grafana server, which is actually still running in Docker. Now, it's actually interesting. If you care, you can actually go into Pyroscope at localhost 3000 and actually see the flame graphs. That's not the purpose of this video. There's great content on Pyroscope. Go learn about that if you want. But it's going to show you a bunch of performance diagnostics for things while they're running. Okay, so what we're going to do is we're going to lock timestamps with Proxymock has a particular time window when it was listening, and then Pyroscope has a time window with its listening. Now, in a real production system, these things would be running all the time, and all you need to do is just transfer the timestamps, and my prompt does that, basically out of the box. So I've already installed my Codex, so I don't require this step, but I wanted to go ahead and show you that. Now, Proxymock has completed both its functional and performance runs, so now we have a baseline that we could put into our CI pipeline, but in the case of this demo, we're just going to go and run it. It does give you some basic CPU attribution, but we need more than this to one-shot it. So, we're going to go and we're going to take things to the next level. Okay, now let's get to the fun part, and that's where we get to the AI to do some of our work for us. Now, first things first, I'm going to make sure that my MCPs are currently correctly installed, so Grafana and Proxymock, I see they're both connected and seem to be working correctly. Now I'm going to use just a demo prompt from a walkthrough here so that you can get an idea of how it's going to use the data. So the prompt here is using the Grafana MCP server, forget that zero, but reading the MCP server, go ahead and see if you can figure out what's wrong, but don't do anything. Now normally you would one-shot a prompt like this if it was in your CI pipeline, etc., but I'm going to show it to you just to see how it works. Okay, now, it's going to take a while, and it's going to grind on this for a while. So the magic of YouTube magic, we're going to, or YouTube time travel, I'm going to skip to the end of this from a run I did previously. Same basic prompt. Okay, it's looking for the profile window, which was created by our test run. Now that profile window only exists in this demo because we want to have Pyroscope and Proxymock looking at the same time frames in order to do the replay and the analysis. Obviously, this would be pre-configured if we were doing an automated snapshot. Okay. It goes through, does a bunch of analysis here, and it figures out that there are a lot of our time here is getting eaten up just by a particular set of trim spaces and other sort of misuses of maps. It doesn't really matter because this is a contrived example, but it used the Pyroscope data, looked at some of the Proxymock data, and it inferred that this is probably where things are slowing down. It does that using eBPF and a set of techniques like pprof from Go, but it's really cool how Pyroscope works. Go check it out. Now, so we have a pretty good idea of what it thinks is wrong. So we're just going to do the first hypothesis now. Now, normally what would happen here is you would go and you'd have to push this all the way to production to get a reasonable facsimile of what's going on. But we're gonna step around that. So I'm going to tell it now to go and actually fix the issue. And then we're going to test its fix. So we're going to give it a second to do this. It goes and gets rid of our rookie coding mistake. And, okay, it's cleaning everything up. Okay, now, what we're going to do to validate the output is we are going to restart the Proxymock mock server, just so we kind of have a clean set here. So this is going to simulate the backend services that our demo app relies on. And then we're going to give Claude one last prompt. Okay. Okay, play. Okay. And this is, again, contrived example, but validate the candidate, check it with Proxymock and Pyroscope. So this is what's going to happen. It is going to go ahead and automatically run the sandbox without us having to configure it. Again, I didn't do anything behind the scenes here. And it's going to test this candidate out, and then it's going to use Pyroscope along with Proxymock to understand if the problem's actually fixed. And so before we even get to production, we will have completely reproduced an issue without a staging environment, without any other kinds of rebuild, and we've isolated a CPU performance bottleneck and actually fixed it, and we know it works because we actually tested it against production. Perhaps we'll skip ahead here, but it's going to go ahead and say that everything worked, and then you can also do some manual validation if you'd like to. It has cut our average latency by about 12x, according to the last test run I made. It is currently getting the sandbox environment ready, going through. And I guess I won't make you sit through the rest of this. So with that is the long-form video of how to do this. Obviously, if you were running things like Jenkins or you have running production instances, the specific DevOps aspects of this would change radically. But hopefully overall, this communicates the overall approach. Anyway, hopefully this was helpful, and thanks for listening.